This will be a short review of order of operations, etc. In this video, we will look at the order of operations, the distributive property, combining like terms, and evaluating expressions. First, the order of operations. Operations refer to what we can do with numbers. For example, we can add numbers, subtract numbers, multiply numbers, or divide numbers. But when there are many operations happening at once within a problem, the order of operations helps us navigate. So, a lot of people like to use PEMDAS, as you see in green here, to remember the order of operations. If it helps, you can consider it as please excuse my dear Aunt Sally. Just a way to remember this order. And I'll go through kind of what to expect for each of these. So parentheses are grouping symbols, also include brackets. Exponents involve a power, so for example 3 to the power of 2, 2 is the exponent. Exponents also include radicals, so for example the square root of 9 is 3. Multiplication, we're used to seeing multiplication using either the times symbol with a little x or the little dot. Also, parentheses next door to each other can indicate multiplication. Division, most commonly we'll see it using this division symbol or a fraction bar. Addition and subtraction, so that's kind of what we're expecting. One thing I'll note, and I'll say this again when we do our example, if you think of the order of operations as a sort of hierarchy of how you move through a problem, keep in mind that multiplication and division are equally important, so we just care for them as they happen left to right. And we'll see that in an example shortly. The same is true of addition and subtraction. So those are basically equally important, and we just do them as they happen left to right. So PEMDAS, or please excuse my dear Aunt Sally, is a way to remember this. We'll just try one example here. So if you have the example 8 plus 14 divided by 7 times 3 minus 5, I'll jot PEMDAS on the side. And picking up on that point we just mentioned, keep in mind multiplication and division are equally important. Same with addition and subtraction. So as I look at this problem, I notice there are no parentheses. There are no exponents. So we do see multiplication and division. The first step I'll do in this problem will be 14 divided by 7 because that came before the multiplication. So here we have 8 plus, well, 14 divided by 7, that's going to be 2. And carrying down the rest of the problem, we still have times 3 minus 5. So I just took care of one operation there. 14 divided by 7 came down as 2. Looking at our new line, 8 plus 2 times 3 minus 5, the order of operations are going to say we better take care of that multiplication. So 2 times 3 will be our next step. I'll just pull down everything else in the problem, so I'll bring down 8 plus 2 times 3, well that's going to give us 6, and we're still subtracting 5. So 2 times 3 came down as 6. At this point we have cared for the multiplication and the division in our problem. What's left? Well, we have adding and subtracting, so we'll just work our way from left to right. That means I'll take care of 8 plus 6 first, giving 14, still subtracting 5. So 8 plus 6 came down as 14. The final operation there of subtraction, 14 minus 5, gives us our final answer of 9. So that is an example of using the order of operations to navigate through the problem. These can get quite a bit more complex, but hopefully this clarifies the process and refreshes your memory. So keeping that in mind, let's look at another important aspect here as we move towards algebra, which is the distributive property. The distributive property is basically a way to clean up expressions. It's very useful in algebra when variables are involved, as we'll see. The distributive property in a formal way can be defined as when you have A being multiplied by, in parentheses, B plus C, that value of A is distributed to both values within the parentheses. So a times b is just ab, a times c is just ac, and there are no longer any parentheses in the result. We're going to try 4 examples, 2 here and 2 on the next page. The first example is a little unique in that it has numbers, no variables. So it's going to be using the distributive property, even though we know the order of operations could clean it up as well. So the distributive property for our first example says to distribute 2 to the 3 and the 4. 2 times 3 would give us 6. 2 times 4 would give us 8. And since these are both numbers, these are like terms, so I'll just add them up. And 14 would be the final result in that example. In our second example, I have incorporated a variable, in this case x. A variable is just used to hold the place of a number. So -3 will be distributed to x, and -3 will be distributed to 7. -3 times x is just -3x. -3 times 7 is -21. In this case, our result, -3x minus 21, has no like terms. We can't combine any further, so we're done. That's a very classic distributive property example. And then just 2 more illustrating this property. So this time we have 5 being distributed to y minus 9 for our first example. 5 times y is just 5y. 5 times -9 is -45. 5y and -45 are not like terms, so we're done right there. Our final example is a little odd. It's probably not something you'll see too often, but in a sense it's backwards distribution because the 3 after the parentheses needs to be given to the x and the 11 in the parentheses up front. So from time to time you'll see a silly one like this, but not as common. So 3 times x is just 3x, and 3 times 11 is just 33. So 3x plus 33 would be our result there. And this is equivalent, of course, to putting the 3 out front of the parentheses. So that would be a more common way of writing that problem. So that's just a little bit about the distributive property. So now I'd like to move our attention towards the idea of combining like terms, which is another very useful thing in algebra. So combining like terms, similar to the distributive property, is basically a way to clean up and to rewrite an expression in a more simple way. Perhaps you've heard the expression, you can't add apples and oranges, or something like that. That basically means that I can add numbers with numbers, I can add like variables with like variables. Like variables would mean I could add x's with x's, or y's with y's, but I couldn't add an x with a y. So we'll look at a few different examples to illustrate this. Our first example is 4x minus 6 plus 7x plus 10. There are a few strategies you might be inclined to use to identify your like terms. I'm going to use an underlining strategy on this first one. So I see 4x here for my first term, and I know I can add 4x with my 7x down the road. So 4x plus 7x would add to 11x. It's like saying 4 apples and 7 apples gives you 11 apples. But also within that problem I had just some numbers, so I know that -6 can be added with +10, and that will give us a +4. So after collecting the various like terms in that expression, 11x plus 4 is our cleaned up result. Okay, let's try our next one. This one gives 3a plus 6a plus 12b plus 6 minus b. And I'm going to use a slightly different strategy just to illustrate another way you could look at this. So I'll go ahead and use shapes this time. Again, you'll find whatever works best for you, and long term you'll be comfortable. So I see a 3a and a +6a, and those are my 2a terms. So 3a and 6a, well 3 plus 6, that would give 9a. Do a little bit more color coding this time. And then I see, looks like a 12b, positive 12b, and a negative b. So positive 12b and negative b would give a positive 11b after combining. And our plus 6, that was the only number in this problem, so he's just going to carry on as he is, as a plus 6. So 9a plus 11b plus 6 would be our final result after combining like terms there. Our final example is going to incorporate a few more variables here. So we have 5x squared plus 10x minus 6 plus 3x squared minus 4x plus 3. So in this problem I have lots of x's, but all those terms with x's are not like. Here x squareds can be added with x squareds and x's can be added with x's. So I'm going to revert back to the first strategy I used of underlining. I'm going to say that 5x squared and 3x squared are like terms. Then I'll say that 10x and negative 4x, those are like terms. And negative 6 and positive 3, those are like terms. So I've kind of thought about in advance what I'm going to be adding. If it helps, you can actually even write them side by side before combining. So I know we're giving lots of ideas here, but I'm just going to rearrange the order of my expression and stick those like terms next door, giving us a moment to process what adding we need to do. Let's see, almost got them all. So I've copied down all the terms, but you'll notice that when I rewrote it, I stuck my x squared terms next door to each other, I stuck my x terms next door, and then I put my numbers next door. So now we can perhaps more easily see the addition or subtraction that could happen. So 5x squared plus 3x squared gives us 8x squared. 10x minus 4x gives us 6x. And negative 6 plus 3 gives us negative 3. So our final cleaned up expression here is 8x squared plus 6x minus 3. And that is combining like terms. Our very final topic for this video will be evaluating expressions. So, as we've seen, an expression in algebra often has variables, and to evaluate an expression means that you'll be given a value of the variable to plug in. So in this first example, the expression we're given is 5x plus 3y, and we are told to evaluate this for an x value of 4 and a y value of negative 2. This tells me that anytime I see an x, I can replace it with 4, and anytime I see a y, I can replace it with negative 2. As I write that down, hopefully you see this line right here and you start thinking about the order of operations we started this video off with. You'll notice I have some multiplication and some addition, so let's go ahead and try this out. 5 times 4 will give 20. 3 times negative 2 will give negative 6. And 20 plus negative 6 gives us 14 as the value of this expression when x is 4 and y is negative 2. So that's one example. We'll just try one more here. This one gives us the expression x squared plus 5x plus 6. So we are told that anytime we see an x, we can replace it with a value of, looks like negative 3 this time. So I'm just writing down the expression we were given, and then my next line, anytime I see an x, I will replace it with negative 3. So I'll have negative 3 being squared, plus 5 times negative 3, plus 6. So negative 3 squared literally means negative 3 times negative 3, so that will give us positive 9. 5 times negative 3 would give us negative 15, and we're dropping down our plus 6. So I'll just go ahead and use the order of operations again. I'll just say 9 minus 15 there is negative 6. Adding 6 more makes 0 as the final value of this expression. So again, this is a brief review, but hopefully that helps recall some of these ideas. It is now time for you to practice, so find the order of operations, etc. practice sheet and try these out for yourself.